Okay, in case you haven't guessed it, this is Mr. Martin, and these are video notes for Geometry Honors. This is section 4.3. We're going to be talking about a very useful theorem for us today. It's called a right angle theorem. Um, and this is going to give us a very useful theorem for us to use in our proofs, and we'll get to how we're going to use it in just a minute. But the theorem says if two angles are both supplementary and congruent, then they are right angles. And if you think about it logically, they're supplementary, so they have to add up to 180, and they're congruent, so two angles that add up to 180 and are also the same, it makes sense they both have to be 90 degrees, which would make them right angles. So let's take a look at a quick proof. I know we don't look at the proof of theorems very often, but this one is pretty straightforward. It just involves a little bit of algebra, basically putting down into a paragraph proof what I just mentioned. So we're given that angle 1 is congruent to angle 2. So here's my diagram, and we can see that they're also supplementary. That's something that we can assume a straight angle. Once we assume the straight angle, we can conclude that they're supplementary. So since I know that 1 is congruent to 2, and since 1 and 2 form a straight angle, they are supplementary, and their sum must be 180. So that means that the measure of angle 1 plus the measure of angle 2 has to be 180. And since 1 is congruent to 2, we can substitute 1 for 2 in the equation, and now the measure of angle 1 plus the measure of angle 1 equals 180. So these are like terms, so we can combine those. 2 times the measure of angle 1 is 180. Solving for the measure of angle 1, that equals 90. So since angle 1 measures 90 and 1 and 2 are congruent, angle 2 must also measure 90. And finally, since both angles measure 90, they are right angles. So, it's just a lot of information to basically state that, we know they add up to 180, we know they're congruent, they've got to be 90 degrees each, which means they're right angles. So the key here is that they are both supplementary and congruent. So I've got a key word here, supplementary, so I'm going to have to prove that in my proof. And congruent, so this is going to be another step in my proof. So these two steps are going to combine together in my proof to get that they are right angles. Okay, so we've got to have supplements in our proof somewhere. We have to have that the angles are congruent somewhere, and then we'll get them to be right angles. So when will this be useful to us? If we're trying to prove that segments, lines, or rays are perpendicular, because once we get that they're right angles, we know that the segments, lines, or rays that are meeting, that are coming together, must be perpendicular. And we're also going to use this to prove that a segment is an altitude, because right now we don't really have a way to do that. Alright, so another useful definition in converse is for perpendicular bisector. So this is something to keep in mind. If a segment, line, or ray is a perpendicular bisector, then it is perpendicular to and bisects a segment. So thinking ahead, we're going to need to prove that it's perpendicular. We're going to need to prove that it bisects, and then we'll bring both of those things together in a final step to say it's a perpendicular bisector. And then the converse says if a segment, line, or ray is perpendicular to and bisects another segment, then it's a perpendicular bisector. So if you're going to try and prove that it's a perpendicular bisector, you're going to have to get it perpendicular. You're going to have to show that it bisects, and again, you'll put those two things together. So keep this in mind as you go through the problem set, and we'll talk more about that later. Let's take a look at a quick example here. We want to prove that we have an altitude. So if you want to pause the video and try this on your own, feel free, or you can follow along. I'm going to put my given information in here. I've got AB congruent to AC, and I've got BD congruent to CD, given And given, let's mark my picture, I've got AB, AC, BD, CD. And okay, so in order to prove that AD is an altitude, I'm going to need to get that I have a perpendicular here. And in order to get the perpendicular, I'm going to need to get right angles. Okay, so in order to get that these are right angles, I'm going to have to use my right angle theorem and get that angle 1 and angle 2, if I can show that they are supplementary, and if I can show that they're congruent, then I can get that they're right angles. So let's start with the supplementary part. I know that BDC is a straight angle. So angle BDC is a straight angle, and we can assume that from the picture. Assume from diagram. And now that I know that's a straight angle, I know that angle 1 is supplementary to angle 2 if the sum of two angles is a straight angle, then they are supplementary. Alright, so I've got the supplementary part of supplementary and congruent. Now I just need to get them congruent. So if I can prove the left triangle and the right triangle are congruent, then 1 and 2 would be corresponding parts. I've already got two pair of sides. I can use AD as a reflexive side. Change that to a 4. So I've got step 5 here. AD is congruent to AD. That's our reflexive property. And then I can prove triangle BAD is congruent to triangle CAD. And we've got side, side, side from steps 1, 2, and 5. And now that I have the triangles congruent, I know that angle 1 is congruent to angle 2 by CPCTC. So I can see I've got the angles are supplementary. I've got the angles are congruent. If angles are supplementary and congruent, then they are right angles. So now I can say that angle 1 and angle 2 are right angles if angles are supplementary and congruent, then they are right angles. Now that I know that they're right angles, I know that AD has to be perpendicular to BC. So AD is perpendicular to BC if segments form right angles, then they are perpendicular. And now that I have a perpendicular, I know that AD has to be an altitude. AD is an altitude, and we're going to use the converse of our definition here. So if a segment extends from the vertex of a triangle and is perpendicular to the opposite side, then it is an altitude. So a lot of things going on here. You know, any of these steps that you have questions about, why we need to have them, or you know, can we do it a different way, make sure you write down those questions and ask me when you see in class. And we'll see you next time.